Can everybody listen to me? Yeah, right? Oh, okay. Uh, like I said, my name is Thiago, and I'm here in a DevOps conference talking about machine learning, and a lot of people make a question, exactly what do you mean about that? Uh, and I have to tell a little bit of a story and to give some context into this. First, I'm Brazilian. I live in the Netherlands for quite some time now. But when I was in college and back in the days, I used to study pure math. I studied pure and theoretical math, and then I started to do some things related to neural networks. And I did my master in AI, and at some point I was just like, this all looks good on paper, but how can this help a company? How can I actually do something on it? And then I started to work more and more towards a software engineering perspective, in the sense that I started to try to build data pipelines. I started to try to automatize and industrialize how we deploy data science. Because one of the principles of data science is that you have this person, sometimes one person from the finance team, from the market team, that have this title data science. They work in their local laptops with CSV, SQL stuff, and then they finish their things. They're happy, they have an accurate model after 3 months. Then they present to the CFO, CMO, CEO, whatever. Everybody gives a pat in their back. You did your job. There's a nice PPT here. Now hand it over to the production team, to the operations team, to the DevOps team or something like that. So I've been always working on to how can we make this handover process a little bit less cumbersome. And a few years back, this bring me to the DevOps movement. For the last few years since I went to the Netherlands, I helped organize DevOpsDays Amsterdam. And I've helped organize some other conferences and some other things, because I realized that this is not a software engineering problem, an operations problem. This is a lot of the cultural problems of coming with it. How do you help this transition? And then I started to work a lot with the concept of the CICD part, the building a pipeline for this data science models, but more than just continuous integration, deployment, and or delivery, we need to do continuous evaluation of the models. If someone changes the hyperparameters of a model, if someone does something different, how does that affect? And how do you keep track of it? How do you keep a trail of what is happening? And for the tooling part and the things that I've been mainly work, I'm an open source guy. I commit to some of the projects. I've been working in cloud projects for the last 5 years, and I've been working a lot recently with more Kubernetes, TensorFlow, Spark, and a nice project called MLflow that I will mention something on it. One thing is, if you have any questions, doubts, remarks, anything, you don't need to wait until the end of the session. Just raise your hand, speak up. And we are in a DevOps conference. And there is something that I always like to talk about it, is that you see a lot of Azure DevOps or DevOps certification and DevOps this and DevOps that. Who here identifies themselves as a DevOps engineer and or works in a DevOps team? Few people? Whoa. Whoa. Maybe. It's better that I use this one. It's going too fast. There was a tweet a few months back from Roy, a guy that said this: DevOps, a model for shared responsibility and a collaboration between Dev and DevOps. And that has a lot to do with the culture part that DevOps conference try to preach, and it's important. That it's hard to fight the market in a sense that DevOps engineers is not a title, blah, blah, blah. You're not going to say you are not a DevOps engineer if they offer you a raise for the title of DevOps engineer. So it makes sense. You are a DevOps engineer. How do you call yourself? You don't want to be called a sysadmin at some point, because that reminds you of the neckbeard saying no back of the scene. But you also don't want to be called a software engineer sometimes, because you want to tell that you know a little bit about operations. So what does DevOps came to solve? What was the problem that arose? Who here read the book, the DevOps Handbook? Some people, yeah. In the DevOps Handbook, they talk a lot about the downward spiral. And let me share this story to see if it rings a bell to what you've witnessed. Um, you work in a company, of course. This company has clients, and you are building software. At some point, someone comes to the sales team, to the product owner, or to someone else and says, I want to build this feature. They translate that into a user story. The developer, the software engineers will build that user story. They will develop something, they will test it, they will do something, and then it needs to be deployed into production. Back in the days, still in some companies nowadays, this was separate teams. They would hand over a jar file, war file, or something to someone actually deploy that into production, and that would be a nightmare because this was the only job of the software development software engineers, developing new features. While on the other side of this room, of this wall of confusion, people call it, you had the operations team that not only had to deploy new things, they had to keep the other things running to monitor and to actually operate their platforms. That means that one side was striving for things going faster, and the other side was striving to make sure that you have things reliable, because in the end of the day, if something goes wrong, the pager that was going to ring was from the operations team, not from the software developers. So this started to go this way, that you start to have this tension between these two sides. This tension would rise, and bring it up, until some point they were not able to meet their deadlines with the end client. The end client would be unhappy, and how did the company solve it? Overpromise it again. We know we fucked it up for the last 2 months, but now everything's going to be right. Now we're going to deliver not just this feature, but this feature and more, just to keep the client happy. They will go to the software engineering team and say like, keep it up, my whip is up. This needs to be deployed. And then the software engineering team would start to cut corners, start to do things together with the operations team to make that feature work in production as soon as possible. This would generate a lot of technical debt that would have to be redeemed in the future and collected with interest. That's why it's called debt. And you would go and on into this downward spiral until some point that the animosity between these two teams were gigantic. Nobody was happy, it was unsafe, and until people decided to quit the companies, go someplace else, because there it would be different. It would not. Until the culture thing would change. And that's the main point of the DevOps movement. And that's the part that I'm here preaching it again. DevOps is not about just automation, it's not just about tooling, it's about culture change. And that's the thing that is important. So DevOps came and solved the problem. So now, you just don't have product talking to the client, passing to development, sending and handing it over to someone else. You have people working in teams, in products, together with IT Ops, QA, InfoSec as one person. So let's not go into the DevBizOps, DevSecOps, DevMLOps, DevAIOps, or whatever. And what does this has to do with AI? Why are you talking about? Like I said, a lot of the AI things now, it's a big hype also. 10 years ago when I was doing my master, AI was just a dream, like deep neural networks. It was nothing that we could do. AI was like a term that was kind of sci-fi-ish, reminded people of 80s movies and Blade Runners and all of this stuff, but nobody actually wanted to build a company on top of AI because everybody would seem that they are insane. But now AI is the hype. Now when I go into clients, I usually get something like this. And usually these phrases come because someone just wants to give like a press release around AI. They want to say that they are surfing in the AI trend and they're doing stuff and blah, 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 blah. And it's of course not the only hype that we are facing nowadays. You have other hypes that are really, really as much important. That people in the same meeting room can say this to me. And now this person that raised their hand and said that is now appointed the VP of product of this company. But then it comes the last one. The guy that follows everyone on Medium, on Twitter, knows all the buzzwords, and comes on with the first and the most impressive strategy of all. This is what is happening now, and people experience this by appointing this person as the master of all things, getting funded, moving to the Bay Area, starting their company and doing things like this. Why am I saying this is because all of this are technologies, and who here working in technology for a few years know that these things come and go. Some of them will stay, some of them will evolve, some of them will change, but this technologies thing come and go. And what is important about all of this, why we are here together, again, I will emphasize again, is the culture change that we need to bring to this community. And to give a little bit of a sting into me and to everyone around, if you look around you here now, on this room, I think I see, what, 1 or 2 women? And I think these are the type of things that we should address. How to avoid microaggressions at work environment. How to insert different people in your work environment. How to make people feel safe. These are the type of problems that we should face, not just the technology ones. The technology ones are the easy ones to actually fix. But going back to the talk, when I talk about AI, a lot of people may think of different stuff. I have my own definition of AI. It's not optimal, it's not the only one, it's not good, but it's my definition, and I want to say because then we know we are on the same page when I'm saying AI. AI for me is making computers capable of doing things that, when done by a human, would require intelligence. So if you're doing an application that is doing something that you look at the application and say like, wow, I think there is a human doing this, or maybe it's automatized or not, and you think, oh, this is AI. But machine learning, on the other hand, is encapsulated inside AI. It's a way of doing things. It's a way of making machines find patterns without explicitly programming them to do so. And I say that by the sense of, if you're doing a image recognition app to say hot dog or not hot dog, then you can look into it and say, I can program this. If it's a pixel image, I can compress it. If the first pixel is RGB 255 133 blah blah blah, and the second pixel is this, and you go all the pixels, you can build if-else clauses into this if you are insane. It's possible, but doesn't make sense. The possibilities are almost infinite. So it makes more sense to actually train your algorithm based on data sets. So this is what machine learning does. There are different types inside machine learning. You can use simple linear regression, general linear models, deep neural networks, supervised learning, whatever you want. Machine learning is just encapsulated inside of it. And why is it important to mention this is because when we think about the way that the majority of the softwares that we deploy into production, that we spend these last years taking care of the null pointer exception in Jenkins, to make the CICD pipeline actually work, to make the test, to use Cucumber, to make everything that you want, on the majority of this traditional software development, they revolve around what? If and else clauses, loops, returns of functions, and things like this. We didn't build a lot of the things that we had today based on a system that would learn from the data. We built things based on a system that would, based on this function, if this, then that, return this, then that. This is how we build things nowadays. And this is different because when you studied computer algorithm or graph theory, or depends on the university, you would actually go into something like this. Your algorithms, your applications usually revolves around a process that starts with a decision. If this, then you have a sequence of commands, then you return a value. If not, you go to another decision, sequence of commands, return a value, and so on, so on, so on. The difference of doing this is that, first, it's easier to test, easier to debug with println or console logs. You can do this because if you do an application that should, for example, schedule someone to give a talk at 1 p.m., like an agenda thing, and when you set up the 1 p.m., it would schedule for 3 p.m., you would be able to easily go into that code, to that algorithm, and find where the bug resides. The bug resides on this sequence 2 here. I'm not catching everything. I'm trying something, but the exception is missing or whatever. You can try to debug this. With machine learning algorithms, this is tricky. If I'm saying, again, the hot dog or not hot dog thing, if this is not a hot dog, but it actually gets tagged as a hot dog. How can I fix this? I cannot go into the algorithm and fix this one case for this one edge thing. I have to retrain my entire algorithm to try to catch that problem, but maybe something else that was not a problem will arise now, because you have to retrain everything. You cannot just learn for that specific case. And that makes things, again, very, very different for your pipeline. Because ML, machine learning, revolves around hyperparameters and data pipelines. I'm in a DevOps conference now, so when I talk this to data science, it's hard to give same feeling about what I'm talking about hyperparameters, but everybody, I think a majority of you here know what Kubernetes is and or are working with Kubernetes. So when you talk to Kubernetes and want to deploy something, you don't go into the Go level, to the low level of the API to actually deploy a new operator or to instantiate a new replica set or something. You just go into the manifest and you use the manifest. So you are talking in the whole level, in the high level of it. You're talking in hyperparameters level. It does the same thing with machine learning. Unless you work for very, very specific use cases, you're not going to build your machine learning algorithm from scratch. You're going to use TensorFlow, you're going to use Keras, you're going to use Caffe, you're going to use PyTorch, and you're going, based on the data set, select an algorithm and specify which parameters I want my algorithm to run. This is the important part into this. But the most important part is a lot of discussion in this last 5 years around machine learning have been around algorithms. But what I found out working into clients, and a lot of people also found out, is that the majority of the issues that people try to solve could be solved with general linear models if the data was right, if the data was good. So the data pipeline part, it's the most important one. Otherwise, you get to that old garbage in, garbage out bullshit thing. You need to focus on the data pipeline. And building a data pipeline, on the other hand, is a software engineering problem. Because it always starts with the business problem. And the business problem, you try to answer a question and you look at where? You look at the data. You start looking at the data and then you try to do something with it. You start usually with a manual ingestion. Why? You don't know if your problem can be solved with that data set or if that problem is actually a problem. So you go into a data warehouse, you do a SQL query, you extract a CSV, or you get a CSV from someone else or whatever, or a TSV file or something. But you usually start with a manual ingestion process. This is your first data pipeline. Even if it's manual, it's a pipeline. Then the data science usually started to explore that data set, to clean the data set, and start to do feature engineering. Feature engineering means trying to create some sense of the features. If you have like 300 variables, you may try to reduce the dimensions of the variables to make something more graphically visible. You may try to explode some variables that have, for example, what is the country of this? You may try to create like ones and zeros of this in Netherlands, in Poland, in Brazil, and create more variables of this. So you have to do some feature engineering on top of that. After you do this step, and you realize, ooh, this is something that can actually answer this business question, then the data science usually comes into the sense where they start to develop their model. And when you do this step, when you realize that you can actually answer the question, that is the point where data science can actually change their manual ingestion to an automated way. And this is just a very, very, very important precaution that data science needs to do. Because if you don't automate that first step of your machine learning process, then you are kind of problematic. Because if that model actually becomes into production, you cannot do SQL direct queries into CSV, into something, and expect that to work well. You have to automate your ingestion pipeline. But when data science are working on their model development, they usually do three things. They select a model to train, then they test their model, and they fine-tune it, and they go into this loop. Oh, I already tried this gun with these hyperparameters. I already tried this general linear model with these parameters of this and that and that and that. Sometimes after this, they find something that is really, really relevant for the business, something that really answers one question. So then they think that their job is over. They give a presentation to the CEO. The CEO holds a press release. We are now transitioning to an AI-driven, data-driven, blah, blah, blah company. And the data science gets his raise, goes to work in some other project. But actually, what should happen here is this. They should learn how to operate this model. Not the data science per se, but a team should be on top of this product. And by operate this, they first need to know how to package the model that they want to serve, how to deploy this model, how to serve, how to log, how to monitor, and how to iterate on this process. So all the things that we do when we deploy jar file, the same thing should happen when you try to deploy a machine learning model. And this is important because we can find some problems along the way. And these problems are very much traditional. Usually, when you are talking, oh shit, it's very sensitive. Yes. Usually, when you are talking about machine learning models, you need the data beforehand. If you need the data beforehand, usually, you are not working in a brown field. You already have something working, something running, where you get your data from. So if they have the data that you're getting in a SQL data warehouse or whatever, or MySQL running on InnoDB engine or something, it's not something that you can easily change. You have to cope to work with this. You have to also cope to work with data and API changes. And I say that because sometimes it's your marketing team, they have a lot of data on Salesforce. So you have to extract the data from Salesforce via an API. Salesforce all of a sudden can change their API. Or your data architect decides to change the column on the MySQL database to include the VAT value on the price, and it was not before. So it changes the data. So some problems may rise here. And also, if this works, this is very, very different than other things, is that it requires a lot of specific business knowledge. You need to have business knowledge to answer this question. And sometimes I'm being kind of nice with the business people, but they do not know what they want or they need or what they can get from the data. I can count on, I don't know, at least 25, 30 times that I went to clients that they said like, we have 10 years of data. It will be very easy to create an algorithm. On these 3 years of data, they had 5 platforms and 7 different databases with 8 different data warehouses, with 9 different development teams, that there is no stability, there is no continuity, and just to put that data set of 10 years in a Unity process, it's extremely, extremely tricky. And that means that the business actually, the majority of times, they do not know what they want. They do not know what they need. And of course, working with data, you have one big problem. Data, especially on big corporations, is a very, very political fight. People from this department don't want to give data to this other department, or the other way around, or this is my data, this is my system, this is my application. So it's a problem to cope. And the usual traditional problem, going live. Going live, it's terrible for everyone when they're not doing things right, because they think that, oh, my pager is going to ring at 2 a.m. and they want to fix it. And also, how to monitor, and of course, the ultimate problem of product developments, nobody wants to be on call. And the fact that I say that nobody wants to be on call, operations people have witnessed the being on call as something normal. Development teams are more and more getting into it with the you build, you run mentality. But data scientists, it's really, really tricky to convince them that they are part of a product team, that they need to be a part of the rotation, they need to hold the pager and all of this stuff. And how do you do this? Everything is a cultural change. And what are the extra problems that this data pipeline can bring? First one, data scientists are not software engineers. The majority of them are not software engineers. That means that they do not know what TDD is. They do not know what development is. They don't know what how to make an integration test, and they should not know it. The same way that you should not necessarily know what a machine learning pipeline should look like or what a deep learning neural network is. These are different people working in the same product, and that's normal. But the difference is they should be working on the same product. Besides this, come on, you have this one problem. Everything is worked out, you deploy that to production, but then you realize that you build your data pipeline to automatically add some features to the data and do this and transform here and that, but you start to realize that you're not getting 10 requests per second, you get 300 requests per second. So the process of transforming that data, it won't scale anymore. And this happens a lot in data pipelines. How do you make that scalable? It's tricky, but you sometimes have to throttle, cache something in front of it. So there are some problems that you can solve. And the biggest one, oh damn, 1, 2, yes. Data science, they're not software engineers, like I said, but that means that lots of them, because of the mentality that they are master students, PhD students, they are used to the standards of I need to publicate this as a paper to someone else or blah, blah, blah. They only work with the best of the best, like in the sense that if their model is not what they think it should be, they will not share with people. And that's something that has a lot to do with the local development part, where they have their own machine. Sometimes they buy a 32 gigabytes RAM nowadays because they make sure that they don't need to deploy that into the cloud so nobody can see what they're doing. They're doing the local development. They have the data locally on their own laptops. And the fact that they don't want to share that because they don't think it's good enough means that they lack a lot of the versioning of it. Sometimes you see a data scientist working on a model for 3 months. He finished the model. You go to his GitHub repository. There is one commit. Just the latest one. Just the one that he thought it was good. And this is extremely, extremely, extremely problematic for everybody that works on this project afterwards, because you may come there as a data scientist and feel like, I'm going to try this new algorithm. Maybe that person already tried. It failed, but you're going to spend the resources and things again. And this involves the rework part. Like I said, you go into there, you try new hyperparameters, new things, and you cannot do much because you're going to get the same problems that that first data scientist did. And again, data scientists are not software engineers, so what is packaging for them, right? Like how they can explore that. Deploying? Yeah. Just give me the data and I will put in this Python code, then the parameters on it, and I have it, right? Isn't this serving? Isn't it deployed? And also, it's even harder to measure efficacy now. Let's go back to the hot dog part. If I have a hot dog or not hot dog app, how do I know my app is working? Someone takes a picture, I say it's a hot dog, actually it's not a hot dog. That person is not going to give me a feedback and send me an email like, ooh, at 14:25, that prediction that you gave to me was wrong. That is not going to happen. So you have to measure that thing by proxies. After I implemented this feature, there is the plan that is completely depending on the machine learning aspect. Has my usage of the app improved? Am I getting more money from it? You have to proxy how you measure that, the efficacy and the validity of your machine learning model. And again, all of these problems, there is no silver bullet for this. But the main thing that I found working with data science in corporations is they need a culture change. They need new ways of working. And then I go back to the DevOps movement, like, it sounds so similar to what we're trying to do here in the same room with the community and all of these things. Because we need to change the culture of these products. Who here does not want to work in a product that involves machine learning? Like, actually, who here already work with machine learning in their lives? So I have like maybe 10% of the room. Who here would like to work in a product that uses machine learning? So then we go to like 50% of the room. And that is the part that I say, like, we need to involve this machine learning specialists, machine learning engineers, data scientists into being a part of the product and take them away, steal them from their finance departments and the marketing departments and whatever it is, to bring them closer to what the IT wants to do. Because we are all just one company. So that first picture was just product and dev, talking to InfoSec and QA and IT ops. The machine learning engineers and data science need to be part of this product. And this is the ultimate thing that I say everyone. Like, if your data science team, your analytics team is completely away from the development, there is something wrong there. And you need to be really, really honest with the data scientist. Local data science is dead. You cannot do this. This is wrong in so many ways, like I shared before, but this is wrong because we are now in a more and more remote-based type of work, people working together in same products from different locations, different times. So you need to make it in a way that the collaboration here is the key of these models. And you need to enable CICD for machine learning. It's not easy. It's not easy at all, because versioning data is one of the biggest problems that we have on this area nowadays. And one of the important things is, I talk about it's hard to fix machine learning bugs, but it's even trickier because we have 3 types of bugs in machine learning that I like to discuss. First one is bias, and bias I always represent by this. This was 1 month ago, I think. Amazon had to close their machine learning algorithm that was filtering CVs because it was being completely biased towards male engineers. And that is one type of bias that comes into the data. Because if you look at it, the majority of the software engineers in these rooms are male. So if you don't take that into account when you are doing this type of things, you're gonna end up with problems like this. If you are talking about, for example, building a machine learning algorithm that is gonna say how likely it is that someone is gonna pay their mortgage or not, you really need to be clear about your bias and about your explainability. Because you cannot just say, no, I'm not gonna give you a mortgage. You need to explain why. No, I'm not gonna put you on the next step. You need to give a feedback. You need to explain why. So you need to be careful with this bias. And the other thing that is important is drift. Who here thinks that after you deploy a machine learning model and operational-wise all the requests are being served, you're not going to get any 500s or anything, the job of the data science is done. He doesn't need to touch that model again. A lot of people think this because of the traditional way and also of the word machine learning. The more data it gets, the better it gets, right? So you just leave it there, everything's gonna be fine. It's gonna get to the 100% soon of accuracy. Well, that's not true. Your model usually will drift. Your model will usually become worse within time. You need to revisit, refactor, and recalibrate your model periodically, always with new things. And this has a lot to do with the fragility part. And I say this with one example. Let's say you build a model that is one of the most important features is the GDP per capita of countries. And all of a sudden, Trump decides that they're going to measure their GDP in bananas. I don't know. He can do that at any moment. If your model cannot cope with these changes, with these things, and it starts getting a lot of weird values after these changes, it's a very fragile model. And this can happen for this absurd case that I mentioned, but it can also happen for, like I said before, one of the data architects decide that that column didn't have the VAT in the price, now has the VAT in the price. How your model gonna cope with that? So these 3 things, bias, drift, and fragility, needed to be taken a lot into account when you are using your model. And this usually appears after you deploy your model to production. And that's the point that you really need to monitor and observe how your model is behaving. Again. And again, More than the CICD pipeline, you need to do a CE, the continuous evaluation of your model. How is my model going? I trained this new model on this new data set. It has X% of accuracy. It has this area under the curve, or whatever metrics that you're using. You need to always keep in track to how was the previous model? How was 1 year ago? How was 6 months ago? What data set am I using now? What data set I was using there? What things changed? You need to continuously evaluate your model. So the problems that we're facing here now are 6. Collaboration, how to version your code and your data, how to evaluate your model, how to package your model, how to deploy your model, and how to serve your model. These are the things that we're facing problems now on the machine learning and the data science community now. These things are not clear, are not completely solved, and from the community that is doing the operations, that's usually the DevOps people nowadays, they are a little bit far away from what the machine learning people are doing, depending on the company that you are. So how can we solve this? Besides the culture, how can you bridge this gap of knowledge? First thing is, come on. Oh. Since Spark 2.3, you don't need to run on top of Yarn or Mesos or standalone anymore. You can run on top of Kubernetes. This is a huge gain for the data science team, because then they can start taking all the advantage of running something on top of Kubernetes now. And when I talk this to data science, they'll be like, I don't care, like, much. But it's better, because then the same pipeline, the same tools, the same observability, you have Prometheus by default here, if you're doing it right. You have Istio, you have all the service mesh, you can do a lot of things together with this that makes the life of data science easier, especially for the observability part. Since Hadoop 3.1, 3 months ago, you can now deploy Docker containers on top of Hadoop. And that is also nice for the large corporations that have their big Hadoop on-premise clusters, because they had this gigantic resource there running batch models or streaming or whatever it is there now. And sometimes it was an idle resource, but now you can actually use that to deploy Docker containers on top of that. And of course, Kubeflow. Who here knows and learn or done anything with Kubeflow? 1 person, 2, 3, yes, 3 people. Kubeflow is a framework on top of Kubernetes that has several tools that are really nice for machine learning. It has a Jupyter notebooks, it has a TensorFlow, you can serve your models, you can do a lot of things, and it's and it's actually something built by the community together with Google and a lot of Kubernetes people involved, that we are working on this for the last 1.5 years. And also the new tool, MLflow, from the same founders of Spark, the same people that actually built Spark, it came MLflow, and that's mainly the demos that I want to do. So I hope the demo gods are kind, because I'm going to give a small demo around MLflow. Can everybody? No, definitely not. Now you can see the first one there. I have a very simple machine learning algorithm that gets, I think, 2,000 wines, and they are acid things and taste and tannic and all of the information, and you have ratings between 0 and 10 of how much I like this wine or not. And I said, like, okay, I've done this for some time. Let's try to predict, based on these characteristics, if the next wine is going to be good or not. And to the people here, this is the actual code. And it's a simple Python code that every data science does. The only thing that I need to add this to be working with MLflow, and I'm going to show exactly why MLflow is nice, is to add these 2 lines, import MLflow, and I'm using scikit-learn on this. And actually, when I'm starting to train this, I have to start with this with MLflow start run. That's it. The only things that I need to add to any data science are these two things. If I do this, I can start doing some nice stuff. So the first thing I'm going to show you is the UI. MLflow is a pip package together with some React things that actually show you here. So imagine that you have a data science team and they are working in one experiment. This is the experiment, I didn't name it, so it's the default experiment. You can have different types of experiment. Everything will be on your left side. And you can have different runs here. That will show to me what the source of that run was. And I can do that directly from GitHub. And if I do that directly from the GitHub, he's gonna actually pick it up the Conda environment that is running on GitHub, put it locally, run your TensorFlow or your model, and actually do something. And I specify some parameters here, and it will show me the actual metrics of it. The advantage of having a tool such as MLflow is that you can actually compare things. So for example, if I want to compare this parameter with this parameter and this parameter, I can click here, and I can have like a scatter plot of my metrics that I use. And I say like, oh, based on my alpha parameter, I get the medium average as 0.6 something. It doesn't change much. And one of the nice things of doing this is that this allows you to collaborate more with people and actually do the continuous evaluating part. But one of the important things here is also the possibility of, let's say I'm gonna train it again. Let's train with alpha parameter 0.9 and L1 as 0.12. Oh yeah. Need to activate. So I get here my R2, all of things here. And if I go back to my runs here, and I refresh it, I'm going to have a new run now, here now. So if you add new metrics, new parameters, you will keep track of it all the time. You can also name your files, your sources to be more like descriptive. So if you're doing deep neural networks, you can say this rnn.py or something, and you can keep track of it. Okay, this is all okay-ish, cool. But what if I want to serve this model? Let's make it bigger. So this one here, I'm actually using MLflow, using the library that I use to actually build this algorithm, to actually package the algorithm. And I say, I'm going to serve this. And I'm going to serve what? I'm going to serve this model with an artifact. So every time that I do a Python run and there is a MLflow there already, it's going to already automatically package that model in a place that I can serve as a REST API. So if I do this, it's actually telling me that it's going to serve this model in this port 1235. So it's running there. So, okay, let's make it bigger again. So if I want to actually test if this new wine that has this acidity, this volatility, this sulfur dioxide, all of the data that I need to actually train my model, I need to serve it. If I post this, I'm going to get an actual prediction of this model, saying that, yeah, this model, this actually wine with these characteristics according to your model will be a 5.45. And this is just a REST API that you can deploy anywhere you want. So by using tools like MLflow, like Uber's Michelangelo, like Kubeflow, Tflow Server, many other tools that are appearing more and more recently, we can actually try to solve some of the problems. So, for the problems that we have that I pointed out, the first one, that is by far the hardest one to solve. Because all of this is tooling. This one is tricky, and this one has a lot to do with why we're here. We need a culture change on this field. We need to have a better collaborative environments, safe environments where data science that are usually academic persons can actually showcase that my shitty model had 40% of accuracy. Yeah, commit that to GitHub. Let people learn that that doesn't work for this data set. It's not harmful for anyone to do this. The version part is push your data science to use Git all the time. It's not working, it's not good, it's not this, it's not that. Yeah, cool. The end of the day before you go, commit. Versioning data, ooh, that one is a little bit tricky. Some people, if you are querying on a data warehousing or something like this, then you need to version on the timestamps or the things that you are doing to keep it there. But depending on the data sets and stuff, it's hard to do data versioning. I admit that. There is no perfect tool for it yet. If you are on the cloud, you can do some nice things, like if you are on S3, it's good to generate a data set, put on S3 and enable the versioning of the bucket and attain your model to the version of the bucket. But if you're doing things on premise, it's a trickier thing to solve. Evaluating your model, like I said, I showed you MLflow. MLflow actually takes care of all of this, evaluating, packaging, deploying, model serving. But there are many, many other tools. MLflow is open source, as is Uber, Michelangelo, Aries, Tflow, Aries, Kubeflow, and other tools. None of them are perfect yet, because this is something that started the majority of the companies less than 2 years ago. So we will get there, but... So, again, this is what I want to show to you and to explain that this is a cultural problem that we need to fix. And I'm here for questions. And a shameless plug, if you want to come to the Netherlands, we're hiring. Thanks.